Today we will go over geometric optics. Now basically optics is the cornerstone of photonics systems and applications. Now photonics is an area of study that involves the use of radiant energy, which in this case would be light, and it's basically just a branch of technology that's concerned with properties and transmission of photons. So today we are going to get a better understanding of geometrical optics, and we're basically going to further understand the basics of light reflection and refraction. Now with reflection, we basically start with an incident ray. It's going to come and hit a medium, any particular medium, and it's going to reflect off. Now with refraction, it's basically going to be a light ray coming at a particular angle, hitting our second medium, which in this case would be glass, bending or refracting internally, and then once leaving that medium, it's going to hit our third medium, which would be air, and it's going to bend or refract again. The type of lens that we're going to use for this simulation would be a convex lens. Now basically what this shows is we have many light rays coming from this particular direction, and it's hitting our convex lens. So once it hits the very first interface, or the first side of our convex lens, it's going to refract, and then it's going to come out from the other direction. Now, all of these rays are basically converging to one particular point. Now this one particular point is called our focal point. After clicking the simulation link, this is the screen that you're going to be seeing. As we continue to scroll down, this is the table where we will fill in our missing variables. Now, once we click onto the simulation link, this is the main screen that we are going to be seeing. So basically, all we are going to need for this simulation would be our ruler. Now, for instance, if I were to set my curvature radius at 0.55, our refractive index at 1.53, and our diameter at 0.8, I would like to find out our object distance and our image distance. So our object distance is going to be from this tip of the pencil all the way to the lens. Our image distance would be from the lens to this other refracted image. So basically now I would grab my ruler, I would put it at the very tip of the pencil, and I would read how many centimeters across this object distance would be, which in this case would be 150. So I would just go to my table and I would either write in or type in 150. Now, for our image distance, we're going to do the exact same thing. We're going to grab our ruler, place it in the very center of our lens, and read across how many centimeters our image distance would be. Now, if we were to look back at our table, we see that some variables are given while others are still missing. For this case, what we would do is actually grab this little move me icon, and we would either bring it closer to our lens or further away. So in this case, if I needed my object distance to be 200 centimeters, I would just basically place my ruler next to my lens, and I would grab my object. And this is how I would set a fixed object distance. And then I would solve for my unknown image distance. Now, once you complete filling in all the variables of the table, you will then answer these 3 questions and begin taking the quiz for this particular simulation.